We are in the middle of a straight-up revolution with artificial intelligence. I mean, today's large language models can write code that actually works, they can pass the bar exam, they can whip up incredible creative text. They're like digital geniuses. But, all this progress has created this really fascinating paradox. So let's get right into it. How is it possible that an AI has the smarts to pass one of the hardest professional exams on the planet, but it can't handle a simple chore like folding a towel? Why can these systems that juggle complex legal arguments get, well, butterfingers when they have to juggle actual butter?
And that's the big mystery we're going to unpack here. The answer isn't about more processing power or feeding it more data. Nope. It's about something way more fundamental, something these AIs are missing that we humans just take for granted every single second.
To really get this, we have to start with one single powerful idea: the AI's total disconnect from our physical reality. Think about it. Today's models are brilliant, for sure, but they're also kind of like ghosts in the machine.
That missing piece, it's called embodiment. Now, you might hear that and just think, oh, it's about having a robot body, but it's so much deeper than that. Embodiment is this constant two-way street between a mind and a body that is always sensing, always acting, and always learning from the world around it.
Let's break that down a bit. This embodied intelligence, or what you might call grounded intelligence, it's built on these pillars right here. It's about being able to see, touch, and hear things for yourself. It's about skillfully grabbing and moving objects. It's about physically being there and feeling the consequences of what you do. And this is the big one. It's about learning by doing, not just by reading about it.
This quote just nails it, calling them disembodied oracles. It's perfect. They've absorbed almost all the text humanity has ever written, but they've never felt the weight of an actual book, or the warmth from a fire, or even the sting of a tiny paper cut. Their knowledge is huge, but it's just abstract. It's not grounded in reality.
So what happens when an intelligence grows up without this grounding? Well, you start to see some really strange, really telling limitations. It's like a kind of common sense blindness that just shows the huge gap between knowing a fact and truly understanding it.
Just think about this simple question. Any kid who's ever played with cups in the bathtub knows the answer instantly. It's not something you figure out with logic. It's just something you know because you've seen it 1,000 times.
A human answer is immediate, right? The water overflows. But an LLM, which is just working off of patterns it found in text, might spit out an answer that sounds plausible but is physically impossible. It just has no intuitive feel for things like volume or gravity. It learned about physics by reading words, not by making a mess.
Or think of it like this. An LLM can write you a beautiful poem about slipping on ice. It can use all the right words it's seen connected to that idea, but it has absolutely no access to the actual feeling, that sudden pit in your stomach, your arms flailing wildly, that raw bodily knowledge. Its understanding is just an echo of ours.
So you see, this whole embodiment deficit leads to a whole cascade of related problems. You get the shallow understanding of physics, a major lack of real common sense, the obvious fact that it can't actually do anything in the real world, and this vulnerability to just making things up, what we call hallucinations, because it has no real-world sanity check for its own logic.
Okay, so if the answer is to give AI a body and let it learn through experience, how in the world do we do that? We can't just build a million super expensive robots and let them loose, right? The answer, and the next huge challenge, is all about simulation.
Simulation is pretty much the perfect playground for training robots. For one, it's safe. You can't break a virtual robot or anything around it. It scales like crazy, so researchers can run thousands of experiments at once, racking up centuries of experience in just a few days. And of course, it's cheap and you can repeat experiments perfectly. But there is one giant catch.
And that catch has a name: the reality gap. Because no matter how fantastic your simulation is, it's always just an approximation of the messy, chaotic, and infinitely complicated real world. It's a simplified sketch, never a perfect photo. And this gap comes from everywhere. Just look at this table. In a simulation, the physics are too clean. Objects are perfectly rigid. But in reality, things bend, they vibrate. A simulated camera is perfect. A real one has lens flares and static. A simulated motor is instantaneous. A real one has delays and power dips. So a robot that gets an A+ in the perfect world of simulation can fail spectacularly in our imperfect one. So the real cutting edge of robotics today isn't just about building better robots. It's about building smarter ways to bridge this gap, to teach an AI that grew up in a video game how to survive and thrive out here in the real world.
And researchers have a pretty clear recipe for this whole sim-to-real process. You build the best simulation you can, you measure and shrink the gaps you know about, but then comes the really clever part. You have to train the AI to be tough enough to handle the unknown gaps, the stuff you could never model.
And one of the most powerful ways to do that is a technique called domain randomization. The idea is actually pretty simple but brilliant. If you don't know the exact friction of the real-world floor, then just train the robot on thousands of simulated floors, each with a slightly different level of friction. You do the same thing for lighting, for colors, for object weights. By training the AI on this huge range of possibilities, the real world just ends up looking like one more variation it's already seen. It makes the AI so much more robust.
So when you put these two huge ideas together, the need for a body and the challenge of bridging that reality gap, you start to get a really clear picture of what the next great leap for AI actually looks like. It's not really about language anymore. We've made mind-blowing progress there. We're getting really good at abstract reasoning too. But just look at this. Physical interaction is where we still have so far to go. Mastering the messy physical world of atoms, not just the clean digital world of bits, that's the next great frontier. And that brings us right back to where we started. True, adaptable, common-sense intelligence. Maybe it's not something you can just program. Maybe it's something that has to be grown, through experience, through trial and error, through a body. Which kind of leaves us with one last big thought. For all the focus on building bigger models and using more and more data, maybe the path to the next level of AI isn't hiding in a server farm. Maybe it's waiting in a sandbox.